All right, so just a little bit of review, Mac. A little bit of a review for naming and drawing alkanes, alkenes, and alkynes. Remember, break it on down. I find it a lot easier to draw from the name than to do it the opposite. But let's go ahead and again, just a little review. All right, and again, if you want to take a note down, you can. If not, then certainly just kind of paying attention. So let's say we have something that looks like this, and again, just a bunch of carbons, and let's put some branches off of it. And here we go, something like that, and let's keep it as that simple right there. Okay, the first thing we want to do is find the long chain. And the long chain, to me, looks like it just simply goes through. Remember, it must go through the double bond. The long chain must go through the double bond, so that's part of it. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so it's an 8-membered long chain. Then we start to take a look at branches. This branch is a methyl. This is an ethyl. This is a propyl, and this is also a methyl. Alphabetically, we need to go with the ethyls first. So, how are we going to name this one? 4-ethyl. The dye would be used for when there are 2 different ethyls, because it's off of the 4. The 4 tells me where it's off of which carbon. Okay, so the diethyl would be only if we had multiple of them, which we're going to see here with the methyls. So now our methyl is off of the 3 and off of the 5. So 3,5 dimethyl. And someone was asking me the other day, you know, why do we even need to add the di? Because if we have the 3 and 5, then we know that we have 2 of them. One off the 3, one off the 5. But obviously, the way that it's done and the IUPAC way of naming these, the dye is used. I really wouldn't have a problem if you called it 3,5-methyl. At least you're telling me that you know it's a methyl off of the 3 and the 5. That would be fine, but for our purposes at least. But if we're going to do it the same way that they do it across the world, then this is how you do it. And then we move to, off of the 4, we have a propyl. So remember, these numbers in front of what it is, methyl, ethyl, propyl, is where it's coming off, where your branch is coming off. Then we have a double bond, and the double bond comes after the second carbon, so 2, and then that's it. So now we go to how many we have? Octene. And again, it ends "ene" because it's a double bond. All right? So that's how you would name this structure. Okay? One last review, and then I'll move to the next thing. And I really don't have a lot to do today, and we should be able to get through this pretty quickly. So let me go ahead and put out another name. Let's go 5-butyl. How about 4,4-diethyl. 3,5 no, let's change that. Let's go 2, 3, 6 trimethyl, 5 propyl decane. Okay, so pretty long, pretty impressive looking thing, but to draw it, it's really pretty straightforward. The first thing you're going to want to do when you're drawing one of these is look at what? The long chain. Absolutely. So if we say we have a decane, let's just pop out 10 of these. I don't know how many I'm at. 1, 2, 3, 4, 5, 6, 7, 8, 10. That is awesome. Okay, now let's just go right ahead and put some branches on. Off of the 5th, I've got a butyl. How many is but? 5, 4. Off of the 5th one, we have a 1, 2, 3, 4-membered branch. Off of the 4 and 4 we have diethyls. So 1, 2, and then another 2. And then off of the 2, 3, 6 we have methyls. So 2, doesn't matter if they're up or down. 3 and 6 we have methyls. And off of the 5th we have a propyl. 1, 2, 3. And this would be the drawing for that crazily named substance right there. Okay? Again, you should be able to figure out how many hydrogens there are. How many off of this first carbon? Yes, 1, 2, 3, because each carbon can have. How many off of this carbon right here?
1.
Just the 1. How many off of this one? 3. How about this one? 1. Okay, and we could keep going. All right, so we could figure out our hydrogens. All right, let's call that good.